So let's go over the solution to this practice problem, which requires you to fill up these 1, 2, 3, 4, 5, 6, 7 piezometers with water so that they determine heads that force the groundwater flow to flow from high head to low head along the flow path that's shown here in the light gray arrow. So the water is starting right here at this point right there. We'll call that point A. And it's going to go and end up right here at this point here. And let's see. As it does that, it is going to pass through the points B, C, D, E, F, and G, and H. And so we'll call this point I the final point. So remember, water is flowing from high head to low head from A to I. So it better be true that the head at A is greater than the head at I. So we have to apply some head generalizations here to determine the heads at the beginning and end points. And just for arbitrary reasons, let's just set the datum at the bottom of our slide somewhere. So the red line down here, that's the datum elevation. And we know that at point A is on the water table. So the head on the water table is equal to the elevation of the water table above datum. So if that is this distance here, this is the head at A. It's the elevation of that point above the water table because it's on the water table. Sorry, the elevation above the water table above datum. The head at point I lies at the bottom of a stream. And the generalization here is that the head at the aquifer at the bottom of a stream is equal to the elevation of the surface of the stream. So the head at I is equal to this distance here. That's the head at I. And hopefully you can see that the head of A is greater than the head at I, so water is indeed flowing along the flow path that I've shown, the gray arrow, from high head to low head. And our job is to fill those piezometers in between up with water so that we continue to maintain the rule that groundwater is flowing from high head to low head. So let's start with the first piezometer here at B. So the piezometer here, remember, measures the head at this point here. And this head has to be lower. The head at that point has to be lower than the head at A. So I'm going to fill it to sort of this level like here. All right. I don't know exactly where it is, but I know, having done that now, that the head at B, this is the head at B, right? This is the head at point B, and that is going to be a smaller number than the head at A. Same logic would tell me that the head at C has to be lower than the head at B, so I'm putting it in like here. And I can follow that whole process all the way down. Let me actually go all the way to the end here, because this is where often people kind of mess up here. So again, the head at I is equal to that elevation of the water surface. If the head is going to flow from the point at H to the point at I, the head at H has to be greater than the head at I. So it has to be something like this, something above the head at I. So fill it in like this. So the head at this point H here, head at H, will have to be equal to this distance here, and we can see that the head at H is greater than the head at I. And we now have to slot in the rest of these heads so that they maintain the decrease in head as we go along the flow path from C to E, D to E to F to G. And I'm going to do that kind of like this. Now, as I do this, it's really important that you not be tempted to simply fill in the piezometer so that the head is equal to the head at the water table. That may or may not be true, and in fact, in many cases, it's not true. It's not true, for example, at H, it's not true at G, it's not true at C, and it's not true at D. And if I see you in an exam, for example, simply fill all of these heads in equal to the heads at the water table, I'm going to mark it wrong, because I'm going to think that that's what you think is how you should draw the heads. The water table is not relevant in this problem except for at point A. At point A, the head is on the water table, so the head is equal to the elevation of the water table. At points B, C, D, E, F, G, and H, the only relevance is that the only important thing is that the head must be continuously decreasing as we go from A through I. So don't be tempted to locate these heads exactly at the water table. That is not the right answer. And if I see that, I will assume that you don't understand how to correctly solve this problem, and I will mark it wrong.